fish. So in that example is they do a very beautiful experiment where they looked at the sign stimulus. They're trying to identify what the sign stimulus. So the sign stimulus was red, the color red. Kind of like, they say like gold, so I think there's more to it than gold than that. But in these fish, when they looked at reproduction, they looked at a red belly. So you could have this thing that looks nothing like a fish, but that had a red belly and it's floating, and then they would attack it thinking that it's another competitor for mating, and so that's a good selection pattern. So when they see the sign stimulus, they're going to attack. They're not going to think about it. They're not going to, and it doesn't have to look anything like the real thing. It's just what that is. It is a sign that stimulates some sort of action.
And then they do the action to completion, right?
Yeah.
Okay.
So that's probably lower in terms of neuronal recruitment than the classical conditioning operation. There's more processes involved in both types of conditioning.
What are you doing, no?
Possible has something else figured out.
Miss Leslie, is it true that like plants tend to grow better when there's like, or like the flowering of plants occurs when in like uninterrupted darkness, not necessarily like sunlight? Is that like, because that's what the book's saying. It's like talking about that plants actually flower according to the amount of uninterrupted darkness.
Yeah, so there are they're called phytochromes. So I tell you what, you're sort of jumping all over the place with this one. So the answer to that question is yes and no. There are some things called phytochromes. So there are these light detectors that are found in plant cells, and there are what are called like short day versus long day flowering plants. So they detect the length of darkness. And so if you interrupt that period of darkness with lights, you can get them to flower at different times. But really that comes back to this concept of long day, short day plants. And they're detecting the amount of what's called far red and near red light. But it has to do with phytochromes. So the big idea there would be cell signaling and responses to cell signaling using phytochromes.
Okay. Got it.
You want me to elaborate on that?
No, I think I got it. Thank you.
Yeah, so that's really just the concept of interrupting a particular pattern that it would expect.
Okay, and then one more thing. So when we're talking about tropisms, that's mainly referring to like plants like responses to like external stimulus, right? Like, let's say some sort of branch that's like the stigmatism. Yeah. And then like phototropism is like when they bend towards the sunlight, right? Outside.
It's inside too. Remember, I showed you the plant.
Yeah, the window and the pea plant.
Yeah, exactly. Yeah, so that's so I'll be covering that in April. So we'll